Stochiometry. I'm going to show you some quick steps to hopefully help you out.
Okay.
The problem for our in-class work from mass to mass theoretical stoichiometry practice. Problem number 3, it's on the back side. The problem says that we have propane reacts with oxygen to give us our combustion products, which is carbon dioxide and water. And the first question, question A, says, what is the mass of carbon dioxide formed if 5 grams of propane are consumed in the following reaction? So the first step, make sure to write out the reaction if it's not given. In this case it's given, so you just copy it. And the reaction is C3H8 plus O2 yields CO2 plus H2O. Step 2, it says to balance the reaction if needed. Okay, so I'm going to quickly help you guys out here. Remember to separate all the atoms on the left side, separate all the atoms on the right side, and then in parentheses you're going to write the subscripts. For carbon on the left side we have 3, hydrogen we have 8 of them, and oxygen atoms we have 2 of them. On the right side we have 1 carbon atom. On the right side we have 2 oxygen atoms and CO2, and then hydrogen atoms we have 2 on the right side, and oxygen we have 1. The first thing that you need to do is balance the hydrogens here. There's 8 on the left side and there was only 2 on the right side, so then you need a number to multiply it to give you 8. In this case it'll be 4. So therefore you're going to write a coefficient of 4 in front of the water, and that does not only affect the hydrogen in water, but it also affects the oxygen in water. So therefore we have 8 hydrogen atoms and 4 oxygen atoms on the right side, so forth. And then we have to take also into consideration that we want to balance the carbon, because there's 3 carbons on the left side, 3 carbon atoms, and only 1 carbon atom on the right side. So therefore you're going to put a coefficient of 3 in front of the carbon dioxide molecule, and you're going to multiply the 3 times 1, which gives you 3, and then the 3 times 2 oxygen molecules will give you 6, and therefore we end up with 6 oxygen atoms. Now you're going to add the 6 oxygen atoms plus the 4 oxygen atoms here, and we end up with 10. So therefore we need to balance the oxygen atoms on the left side, and we have 2 of them so far, so you're going to multiply that by 5, gives you 10. Okay. Step 3, you got to identify the given and the unknown. You have to refer to the problem, and the problem states that what is the mass of carbon dioxide formed if you have 5 grams of propane. Okay, so the given is 5 grams of propane, which is C3H8, and your unknown, or what you want, is the grams of CO2. Okay. Step 4, you got to use the molar mass. Okay, you have to find the molar mass of the given and molar mass of the unknown. The molar mass of the given is C3H8. You have 3 carbon atoms and 8 hydrogen atoms. The mass of carbon is 12, the mass of hydrogen is 1. You multiply across, so 3 times 12 gives you 36, 8 times 1 gives you 8. You add those 2 numbers and you end up with 44 grams per mole. That's the molar mass of propane. Do the similar thing to carbon dioxide. 1 carbon atom, 2 oxygen atoms. The mass of carbon is 12, the mass of oxygen is 16. You multiply across, you end up with 12 times 1 is 12, 16 times 2 is 32. You add those 2 numbers and you end up with 44 grams per mole. Step 5. Here you have to find the molar ratio. Here I gave you something so that you can refer to. You have to refer back to the chemical reaction and the balanced one for that matter. We have here, you have 2 ratios. The coefficient, whatever the coefficient of the mole of the given over coefficient of mole of the unknown. And then you do the reciprocal. These are going to be the conversion factors required for you to convert from moles of the given to moles of the unknown. Okay. In our situation, 1 mole of C3H8, which is right here, and we got that 1 mole because of the imaginary 1 right here, and then the 3 moles of CO2. Okay. And then of course we get the reciprocal when we realize when we set up our problem is the one we're going to use is the one on the right side. Okay. Step 6. Here is a T-chart to help you somewhat set up your problem once you have all the information required above. This T-bar is required if you're going from grams to grams. If the problem is giving you, if the problem requires grams, and you're going all the way to grams of an unknown, then this is what you use. Okay, and if you realize here, you're going to start off with the grams of the given. Right here, you're going to divide by the molar mass of the given in the first set of right here, where the grams of the molar mass are at the bottom and the moles of the molar mass are on the top. The next portion right here is the mole ratio, and if you refer to the previous slide right here, I told you that this is the one we were going to use, okay? Which is coefficient of mole of unknown over coefficient mole of the given. Lastly, you're going to multiply it by the molar mass of your unknown, okay? So referring to problem 3 that we're doing, okay, here's what you get, okay? Since we have started off with 5 grams of the given, okay, we're going to refer to, what is it, slide 2, where it tells us the molar mass of our given, which is propane. So we're going to divide by the molar mass of that, which is 44 grams of propane. Then we're going to use the mole ratio. Remember I told you is this one on the right. And lastly, we're going to finally multiply by the molar mass of CO2. Okay, so our units ended up canceling out for grams of propane, moles of propane, and moles of CO2, leaving us with grams of CO2. If you realize right here, you really don't need a calculator because 44 divided by 44 is 1, and so all you have to keep in mind is 5 times 3, which is 15 grams of CO2.